Hi all of you. Welcome to another lecture of antenna and wave propagation. This topic belongs to module 3. In this lecture we are going to discuss about binomial arrays, Dolphchebyshev arrays, its design procedure, and a little about the grating lobes. What are binomial arrays? It is an array in which the amplitudes of the antenna elements in the array are arranged according to the coefficients of the binomial series and an array with non-uniform amplitude. That is, binomial array means it is an array with amplitudes of antenna elements in the array are arranged according to the coefficients of the binomial series. Let us see what is a binomial series later. The amplitudes are arranged in such a way that the resultant radiation pattern has no minor lobes. In the previous lecture, we have seen broadside arrays, end-fire arrays, and so on. All those type of arrays had some minor lobes, but in this case, there are no minor lobes present. That is a speciality of the binomial arrays. To reduce the side lobe level of linear in-phase broadside arrays, sources have made amplitudes proportional to the coefficients of binomial series of the form. This is the binomial series. So we make the coefficients in this form and reduce the side lobes, or we make the side lobes almost zero in the case of binomial arrays, where n is the number of sources. This is the binomial series expansion, and the amplitudes are arranged in such a way that the resultant radiation pattern has no minor lobes. Okay. The binomial array amplitudes are arranged in Pascal's triangle. What do you mean by a Pascal's triangle? Look at this. This figure represents a Pascal's triangle. Here you have 1, then you place 2 ones in 2 sides. Again you place 2 ones like this, 1 plus 1, 2. Then again you place 2 ones in 2 sides, 1 plus 2, 3, 2 plus 1, 3. Again you place 2 ones here, then 1 plus 3, 4, 3 plus 3, 6, and 3 plus 1, 4, and again you have 1. Again you place 2 ones in the sides, then you get 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and again 1. Understood? Then the half-power beamwidth of a binomial array is more than that of the uniform array for the same length of the array. Even though the length of the array is same, you have the half-power beamwidth of the binomial array is larger. That is, for a uniform array, you can see it is 23 degree, and for a binomial array, you can see it is 31 degree. Okay, now we are going to see another type of arrays, that is the Dolphchebyshev arrays. Before that, we have to see something from the notes. I think my note will do better. Okay, look at this. A Dolphchebyshev array produces the narrowest beamwidth for a given side lobe level and vice versa. This is a type of array which produces narrowest beamwidth. Then a Chebyshev polynomial is given by Tm of x is equal to cos of m cos inverse of x, and Tm of x is equal to cos h m cos inverse of x if x greater than or equal to plus or minus 1, and here it is if x less than or equal to plus or minus 1. This is the representation of a Chebyshev polynomial. You have to learn it. Now we are finding for different value of m what is the value of the polynomial. Understood? T0. So you put m is equal to 0. What do you get? Cos of m cos inverse of x. Suppose let cos inverse of x is equal to delta. X is equal to cos delta and delta is equal to psi by 2 in this case. You suppose this thing and start the work. Cos of m cos inverse of x. Cos 0 is equal to 1. Then you put m is equal to 1. T1 of x. You find T1 of x. Cos of 1 cos inverse of x. You put m is equal to 1. That is cos of 1 cos inverse of x. That is, what is cos inverse of x? What is cos inverse of x? Cos delta. That is equal to where cos delta is x. Now you put m is equal to 2. T2 of x. You find for each value you find like this. Cos of m cos inverse of x. That is 2 cos inverse of x. Cos 2 theta is equal to 2 cos square theta minus 1. Cos delta is equal to x and cos square delta is equal to x square. So what you get? Cos of 2 delta, that is 2 cos square delta minus 1, that is equal to 2x square minus 1. Understood? Similarly, you find for m3, t3 of x is equal to cos of 3 cos inverse of x. That is cos 3 delta 4 cos cube delta minus 3 cos delta. Because cos of 3 theta is 4 cos cube theta minus cos theta. All these equations we have to learn. Then 4x cube minus 3x. Now we have to remember one more equation. T of m plus 1x is equal to 2x into Tm of x minus Tm minus 1 of x. Okay. Then what do you get? Okay. You find it like m is equal to 4. You find it 2x into 4x cube minus 3x minus 2x square minus 1. Using that equation, that is, we just now saw an equation, and using that you find this. Then you get the value. You find m is equal to 5. Similarly, you find till m is equal to 7. Okay, it is seen that the Chebyshev polynomial of value m has a degree of polynomial same. Understood? That is a Chebyshev polynomial. That is T7 of x will have x raised to 64, x raised to 7. That is, it is seen that the Chebyshev polynomial of value m has the degree of the polynomial same. T7 of x will be equal to 64, x raised to 7. Okay. Hope you have understood. Now coming back to our presentation. That was about the Dolphchebyshev arrays. Now, what are the design procedure of a Dolphchebyshev array? Step 1. Calculate the value of r from the equation. Side lobe level below main lobe maximum in dB is 20 log r. That is, we calculate the value of r. That is, where r is actually is equal to main lobe maximum divided by the side lobe level. That is, r ennu parayunnathu is equal to main lobe maximum divided by the side lobe level. So the side lobe level below main lobe maximum in dB is equal to 20 log r. Step 2. Select Chebyshev polynomial same as that of the array polynomial. Third step, choose array polynomial ET. Fourth step, equate Chebyshev polynomial with the array polynomial, and then calculate the coefficients and take ratios for the relative amplitudes. Now we have one more topic, that is the grating lobes. In uniform linear array, if the spacing between the elements exceeding unity, the side lobes appear which are equal in amplitude of the main lobe, which is known as the grating lobe. That is, if the spacing between, we place 1, 2, 3, 4, etc. If the spacing between the elements exceeds unity, what happens? The side lobes appear which are equal in amplitude of the main lobe. That is, main lobeനൊപ്പം തന്നെ വരുന്ന പോലത്തെ side ലോബുകൾ ഉണ്ടാകും, which is known as the grating lobe. These unwanted lobes, as they cause the array to pick up signals from the unwanted directions. ഇങ്ങനെ ഉണ്ടാകുന്ന lobes will cause the array to pick up signals from the unwanted direction. This is a picture depicting the grating lobes. Thank you so much for the patient listening.